PL SQL Basics. In this nugget, we're going to talk about what PL SQL is and why we use it. PL SQL stands for Procedural Language SQL. Without this procedural language part, all we would have available to us would be simple SQL statements. Insert, update, select, delete. Pretty boring, okay? With the introduction of PL SQL, which has been around for quite a long time, we now have some control flow abilities. For example, we can have some looping if we want to loop through certain records and do something to those. We can have if statements. So then we have more fine-grained control over when we want to update certain records or when we want to delete certain records. The other main reason for PL SQL is for reusability. In other words, we can have particular names for our code, and those names can actually be stored in the data dictionary, and then we can re-execute those by name. So we're just building some building blocks, and then we can call those blocks by a particular name. So in this nugget, we'll talk about the types of PL SQL code we're dealing with. We've got anonymous blocks, which is, you guessed it, these are blocks of code that have no name. And we have procedures and functions, which are stored in the data dictionary. And these are just chunks of code that you can call by name. And there can be thousands upon thousands of lines of execution inside there. And you just say, hey, I want to do this particular function. Just call it by name, and it's done. You don't have to know all the fine-grained details. I don't know about you, but when I get up in the morning, I like to go to Starbucks and I get my special foo-foo coffee. And I like to go there with my friend Jen. And what she does is she always gets the double mochaccino. It actually has a name. Well, there's actually a lot of things involved with creating this special drink. I mean, think about it. Somebody has to grind the beans, pack the grounds in the espresso maker, clean that stainless steel carafe, pour in the 2% milk, steam it, squirt mocha in the bottom of the cup, pour in espresso, then the frothy milk, and so on. But she doesn't have to give all of those instructions to the barista. All she has to say is, hey, I want my double mochaccino. So that's what we would call a stored procedure. We just say, hey, I want this to happen, boom, it's done. We don't have to worry about the little details. I, on the other hand, like my coffee with 2% milk, well actually half 2% milk and half soy milk with a quarter pump of mocha. And I only like my milk steamed just a little bit. And unfortunately, there's not a name for my kind of coffee. So the first few times I went into Starbucks, I had to explain what I wanted every single time. And there was always a different barista there. And so I learned, and I just decided to write down my little formula on a piece of paper. These are the directions. This is what I want, because I'm so tired of explaining. They just get it wrong. So if I write it down, they've got it. So they still have the set of instructions, but it's not really in their data dictionary. Okay, it's not a well-known named thing that's known across all Starbucks in the world. Whereas the double mochaccino, yeah, everyone knows what that is. So my kind of coffee is what we call an anonymous block. Another type of PL SQL code is a package. Think of a package as a way to organize your procedures and functions and variables into cohesive units. So I might store all of my procedures and functions dealing with employee management inside of one package called HR. Another feature of packages is that it provides a namespace. In other words, I might have a procedure called do something that's inside of package A and another procedure called do something inside of package B, and those two procedures might do something completely different from each other, okay, because they're in different packages or namespaces. Think of it like this. In the German language, the word gift means poison. Well, in the English language, gift means a present. It's a good thing. Same word, it's spelled exactly the same way, but they're in different packages. One is in the German package, the other is in the English package. And a trigger is also a type of PL SQL block of code. A trigger is actually stored in the data dictionary, and this is just a chunk of code that reacts to some kind of activity in the database. And so when some condition is true, this chunk of code will be executed, and the end user might not even be aware of it. I've got something similar at home. You know, every time the phone rings, my 3-year-old daughter just mysteriously disappears into the kitchen. And I figured it out. She's getting into the cookie jar. But the trigger here is that the phone rings and she knows I'm busy now. So she sneaks in there and she gets a cookie, and I might not hear the cookie jar and I might not see any crumbs. But, you know, I might get a hint somewhere down the road that, hey, there's some cookies missing. And what's cool about triggers is that you can have a cascading effect with various triggers. For example, I can create a trigger. That's right. I can create a trigger. I can put a mouse trap inside of the cookie jar, and when her little hand reaches into the cookie jar, snap! So the triggering event is her hand reaching into the cookie jar. An example in your database is if we update the salary of some employees, we might want to have that logged inside of a special log file. So anytime there's any update activity, that trigger gets executed and it writes to the log file. So we'll talk in more depth about procedures, functions, packages, and triggers in our later nuggets, but this focus of this nugget is to cover the basics of PL SQL. Okay, so this is where we'll get into our different data types and variables. We have some really basic data types like scalars, which are just simple data types. And then we have composite data types where you might have an array of values, or you might have a complex set of values that you access by dot notation. So I'll show you some examples there. And then we've got reference types. These are a way of passing around complex data types between procedures and functions. We're also going to cover statements and control flow. Without control flow, you're pretty limited in your ability to modify your data in a complex way. So we'll talk about what exactly is a statement. There's simple statements and then there's complex statements. And then we'll look at some of the tools for control flow. For example, we've got if statements to check to see if a condition is true. We've got 3 types of loops we'll talk about. So now if you want to loop through a bunch of departments or loop through a bunch of employees and do something to them, you can. And then we have cursors. You could have inside of your code some kind of select statement that stores a result set, and then you can loop through that result set and process those results. For example, if you want to create a cursor based on all the employees who live in California, you can then loop through each and every one of those employees and say, look, if they belong to Department 10, then do something here. If they belong to Department 20, then maybe delete them, okay? So you can have some really fine-grained control there. And then the last thing we'll talk about in this nugget is exception handling. There's a couple things that can go wrong when you're creating PL SQL. One of them is a syntactical error, and you'll immediately know when you have a syntax error. PL SQL will come back saying, hey, you've got an error on line 5, fix it. Okay? But there's an exception, and that's what we call a runtime issue. And for example, you might try to do something silly like divide by the number 0. That's going to throw an exception. I'm going to show you some examples of some anonymous blocks and then a couple procedures, and then we'll go on and create our own from scratch. The schema that we'll be dealing with is the HR schema, which actually is installed if you choose to install it when you create your database. So I'm going to log in as HR, so SQL plus HR, and let's take a look at the tables that we own. So select table name from user tables. There we go. Now let's just hone in on our employees table. This is the one we're going to play around with. So we do a describe on employees, and really the only columns I want to pay attention to now are the employee ID, first name, and last name. Well, I've created an anonymous block that just gives us the first name and last name of a particular employee given their employee ID, and we've actually hard-coded in the employee ID. Let's take a look at that. So let's pull this into our buffer. I'll say get, I put it directly under my C drive. I called it emp name. Okay, so here's my block of code. Now if I want to execute this, I can just do the @ sign, C:\\, and the name of my script. So let's look at the main parts of a PL SQL block. Line number 1 actually isn't PL SQL, it's actually SQL Plus. That just says, okay, we're turning on the ability to print out lines, and we did that so we can print out lines down here with the DBMS output. So really our block of code is beginning on line 2. Okay, so we have our declare keyword, and if you go all the way down to line 7, that's where our begin keyword is. So anything between declare and begin is where we can declare any variables. Then from the begin to the exception keyword is our main block of code. That's what we call the body. And then we have an optional section called the exception handling block. So I have one here between lines 13 and 16. So really the main chunk of code that's getting the work done is between 7 and 13. So let's talk about declaring variables and our data types and how we declare our variables. So on line 3, we're declaring a variable called EID. So we have the variable name, and then after that we have the data type. So our data types can be any of the standard SQL data types that we've already covered, or we can also have some specialized PL SQL data types that are a little more fine-grained that are not available in regular SQL. You also have the option of assigning it an initial value. Whenever we're doing assignment, we do a colon equals. I know it seems a little strange that we would say colon equals instead of equals, but this feature was just borrowed from the Pascal programming language. That's how languages work. We just borrow bits and pieces from different places. Notice how the line ends with a semicolon. Our statements are always going to be terminated with a semicolon. And then on line 4, this is actually a comment. Anything that starts with a dash dash is a comment. So here I'm just showing you of one other way we could have declared this variable. We could have said EID and then used an anchored data type. An anchored data type is where we say %type at the end, and what we're really saying is that this EID variable is the same data type as the employee ID column in the employees table. So one advantage of having these anchored data types is if the underlying table structure changes, if any of the data types change, we don't have to go in and modify this code again. On lines 5 and 6, we're declaring an F and an L variable. We are using anchored data types again, so F is the same data type as the first name column in the employees table, and L has the same data type as last name in the employees table. It might seem a little backwards at first when you're declaring these variables because from my experience in programming in Java and C and C++, you always say the data type and then the variable name. Well, it's reverse in PL SQL. And one of the inconveniences of this language is that you don't have the ability to declare several variables within the same statement. In other words, you can't say F comma L employees dot blah blah blah. You're just not able to do that. You have to have one statement for each variable declaration. So in this block, we have declared 3 variables, EID, F, and L. And let's go into our main chunk of code here. We have a select statement. Notice that our select statement spans 4 lines and it's terminated once again with a semicolon. So that whole select statement is one statement. If you look at this select statement closely, it looks a little different from what you're used to. Look at line 9. This probably doesn't look familiar to you yet. Here we have a select statement. We grab 2 columns and whatever information is coming back, it's going to be placed into this F and L. One of the rules with SQL Plus is that whenever you have a select statement like this, you have to have it be a select into. And so this select statement must return exactly 1 record. If it returns no records or more than 1 record, it will throw an exception. And that's why we have an exception handler down here. So now that we've populated this F and L variable, then on line 12, we're just printing that out to the output. Okay, so dbms output put line just flashes stuff to the screen. dbms output is a package that's been provided for us already by Oracle, and put line is a procedure inside of that package, and all it does is it's like a print statement. Okay, so this will print out employee, and then it concatenates to that the employee ID, which is 120, and then it concatenates to that a colon, and then the first name followed by a space followed by the last name. So if there is no employee 120, it's going to throw an exception. We get bumped down to this exception handler, and something else is going to happen. So we'll talk in a little while in more detail as to what happens in this exception handling block. Let's execute our beautiful piece of code here. So we do an @ and our path and the name of our anonymous block, and see how it printed out. Employee 120 is Matthew Weiss. Okay, that worked out pretty well. Let's look at another example. More often than not, your PL SQL blocks of code will be inside of either a procedure, function, package, or trigger, something that can be queried from the actual data dictionary. Now, sure, you might be like me and have a few one-off scripts that you might have on hand that are anonymous blocks, and that's fine, but the majority of it will be in the data dictionary. Now, I'm logged in still as HR, and I've already created a procedure called give raises. And what I'd like to do is just pull up that procedure and see what that does inside there. So we can query our data dictionary. We say select text from, And user source is a view that contains all the information about our procedures, functions, and packages. Okay, so we say where name equals give raises. Okay, so this is what our procedure looks like. It looks like we're getting two headings here. Remember how to get rid of the second set of headings here, we can say set page size and give it a really big number, like 999. Okay, / to re-execute this. Now it looks a little better. So here's our procedure called give raises, and looks like our procedure is taking in a parameter. Now we'll talk more about parameters in our procedure nugget, but let's just focus on the basic structure of our block of code. Really, the big difference between the procedure and my anonymous block was instead of having a declare keyword, I have the as keyword. Think of these as being synonymous, okay? So anything that occurs between as and begin is going to be a variable declaration. So in this case, I'm not declaring any variables. The main chunk of my code is from this begin keyword to my exception line, and then my exception handling is from exception to end. We've got a for loop. Okay, a for loop is going to loop through, in this case, certain numbers. So this x here is a variable that's getting declared implicitly. And so the first time we go through this loop, x is equal to 1. The second time, x is equal to 2, then 3, and so on until we're at 11 inclusively. So the last iteration, x will be equal to 11. And you'll see here that my loop begins with the loop keyword and it ends with the end loop keyword. So basically, these three lines here, this one statement, is going to execute 11 times. So let's look at what our query is doing. Let's look at our inner query first, the subquery. Select manager ID from departments where department ID equals x times 10. So the first time through, this is going to be 10. Second time through, 20, and so on through 110. So really all it's doing is grabbing the managers from these departments, and then it's updating the employee who is the manager at that particular department. And we're giving them a raise. Well, what kind of raise are we giving them? Well, we're multiplying their salary times R, which was passed in up here. So that's where we can dynamically pass into the procedure what raise ratio we want. Down in our exception handling block, we're just handling the case when no data is found. Okay, so if no data is found, then null. The null statement does absolutely nothing. Okay, and it is actually useful. I know it seems kind of strange, but this is actually preventing any ugly error messages from appearing. And so if we actually want to use this procedure, there's a couple ways we could call it. We could call it from an anonymous block. In other words, we could say begin, and then our procedure name, so give raises, and then pass in a number. If we want to give everyone a 15% raise, we multiply it by 1.15. And then our end keyword. Okay, so our procedure successfully completed. Another way we could call this is with the exec command and then our procedure name. I'm just going to copy and paste right here, just like this. This is probably the fastest way. Both work just fine. Now I want to roll back all this information because I don't think these fat raises are real necessary right now. But I just want to reiterate that there is a specified structure of your PL SQL blocks. We always have some kind of declaration section. Whether there's any variable declarations in there or not, it's going to be there. Then we have the main chunk of code, and then we have an optional exception handler block. I'm going to talk a little bit more about our data types and variables. We already covered some real basic data types like varchar2, number, date, those that are already, acceptable in regular SQL. Well, PL SQL has some added scalar values. For example, we've got binary integer, and keep in mind this is just a partial list. There's quite a few more. You can, instead of saying varchar2, you can say string. It essentially means the same thing. It's just that the developers of PL SQL were trying to make PL SQL a little more friendly towards real programmers. There's another data type called integer. So if you want to restrict your numbers a little further just to that, you can. So the list goes on and on. You can find the complete list at Oracle's official documentation, so I'll just go ahead and circle that. Let's talk about our composite data types. Composite ones are where it contains more than one value. For example, we have what we call nested tables, or otherwise we sometimes just call these tables, not to be confused with regular tables. We also have V-arrays, which are really similar to tables. Basically, both of these store an array of values. For example, we can store an array of numbers, an array of varchars. We can store an array of dates. And then another composite type is the record. For example, if you've got your employees table, and I think our employees table has like 8 or 9 columns in there, you can create a data type that has the same data types as those columns in there. So I'll show you an example of that in just a moment. Okay, so I'm going to declare some variables. I'm going to call a variable R, and I'll say it is of my employees data type. So I can say row type. This is an anchored record type. In other words, my R variable has the same column names and data types as the employees table. Then I'm going to begin my main chunk of code, and we can do a select statement. Remember, your select has to have an into clause. So we can say select star into R from employees where, and remember the select statement needs to bring back exactly one record, otherwise it throws an exception. So we'll say where employee ID equals 206. Okay, semicolon because it ends the statement. Now my R variable, if there was any data there in employee ID 206, that R variable will have been populated with some information. So to splash that information to the screen, we can use our DBMS output package. We call the put line procedure, and it splashes that information to the screen. So to get the individual pieces of information, we use dot notation. So we say R dot first name, and then we can concatenate to that a single space, and then add to that R dot last name, and so on. And then we are finished. So we can say end. If you want to have an exception handler, it would go here. I'm going to skip that for right now. And then we're done. Okay, so our procedure successfully completed, and it is William Geets. I'll show you another example of a composite data type. Let's take a look at a nested table of numbers. Now, typically these nested tables are going to be used in conjunction with a cursor, which we'll get to in just a moment. So we are going to start with real small baby steps and then build upon our knowledge. I want to create a variable that is a nested table type, but I want to declare that nested table type first. So the way we do that is we say type, and then we give it a name. I'm going to call mine num array type, and then we say what type it is. So it's a table of numbers. So keep in mind, line 2 is just a declaration of a type that you're creating. So then you have to have a variable that is of that type. Okay, so here I'll call this EIDs, and its data type is now num array type. And we're in our begin section. Now, whenever we have our nested tables or V-arrays, we have to instantiate that object. And the way we do that is by saying the variable name and then assigning it. This is what we call a constructor, and you have to have the open-close parentheses. What line 5 is doing is it's just creating the structure to hold the individual values. But those individual values do not exist yet. The way we create those individual values is with the extend method. So we can say eids.extend, and the extend just by itself is going to create one slot in that array. If you say extend with some number in parentheses, then it will create, in this case, 5 slots in our array. I'm actually going to use this extend in conjunction with a loop. Okay, so I want my loop to happen 5 times, so I'll say for x in 1.5 loop. Okay, and now I'll say eids.extend. So each time we go through the loop, it's going to create one more slot in our array. And so when we're doing assignment to each individual slot, we have to use a subscript. The subscript actually starts with a 1. If you're used to Java or C++ or any of those other languages, usually they start with subscript 0. Not so in PL SQL. Okay, so we say eids EIDS subscript x, and we can assign it a value. So I'll say it's equal to x times 10. And just for testing purposes, I'm going to output the assignment here just to make sure that it's working correctly. So I'll use my put line and I'll print out my value. Okay, good. So we need to end our loop and we need to end our block of code. Okay, see how our 10, 20, 30, 40, 50? There we go. So just to recap how you create these nested tables is you declare what type of table it is. So it could be an array of numbers, it could be an array of varchars, dates, it can even be an array of records. Okay, so then you declare your variable that is of that type. You must call the constructor, and then you have to use the extend method to create those individual slots. Now really the only difference between your nested tables and your V-arrays is that your V-arrays are a predefined set. Once you specify how large your array is, you can't change the size, so it's not as flexible. Honestly, that data type is just there for backwards compatibility. Whenever you have the choice between the two, use a table. Like I mentioned, these nested tables are usually used in conjunction with a cursor. So let's do an example of a cursor. Really, a cursor is just a select statement that's inside of your PL SQL block of code, and this select statement can bring back multiple records. So really, this is the only way to use a select statement that has more than one result. We're going to modify our code a little bit. When you're declaring a cursor, you use the cursor keyword, and then you give it a name. I'm going to call mine empcur. And then is, and then whatever your select statement is. So here I'll say select employee ID from employees where department ID is either 50 or 80. Now I just declared the select statement, but it's not actually getting executed up here. Keep in mind here that my cursor declaration is happening in our declaration section, and it's not actually going to be executed until we open up our cursor and loop through the results. For simplicity's sake, let's comment out our loop here, and now we're going to loop through our cursor that we created. So we're going to open it up and loop through it at the same time. The way we do that is with a for loop. So we can say for, and the next word here is your variable that you're implicitly declaring. I can call it anything I want to, pretty much. Okay, so for rec in, and then the name of my cursor, which is empcur. Then we have our loop statement. I always like to finish off my loop so I don't forget it later. Once again, we want to extend our EIDS like that. And then we want to do something with all of the records that we're looping through. This for loop is actually executing the underlying select statement, and it's giving us a result set, and we can push the result sets into this variable that we declared here. So now we're going to do some assignments. So EIDS subscript. Well, what's going to go in this subscript? Well, we want to grab the current value of the EIDS. So there's a method called count that belongs to our nested tables and V-arrays, and that will return that value. Okay, so the first time through, count will be equal to 1 and so on. Now we're going to assign to this the rec dot, and what are the different values available to us in rec? Well, let's look at our cursor here. Our cursor is based on select employee ID. That's the only column available to us in this cursor. So we say employee ID. And then for testing purposes, we can do our DBMS output and see what the value is. So let's output the EIDS subscript EIDS dot count. And we went ahead and saved it, and we can execute it. There's all of our employees. So that looks good. Now let's take this one step further. You're probably wondering, well, what's the practical application of this? Well, now that we have all of those employee numbers inside of this array here, then we could maybe pass that array onto another procedure. So I'll just, we don't have any procedure right now defined, so I'll just comment this out, and perhaps you have a procedure called process emps, and there you could pass in the EIDS. Okay, so this will all fit more together when we get to our nugget on procedures and functions and packages. Our third main data type is the reference type, otherwise known as the ref cursor, and we will cover this in more detail in our package nugget. But just think of this as a real general way of passing data around. For example, you can have a procedure that takes as its parameter a ref cursor, and that ref cursor can pretty much be anything. You might pass in a table of numbers, you might pass in a V-array of employees. It's pretty open-ended. We've already covered a couple control flow statements, such as the if statement. I do want to show you a variant of that. So what we're going to do is modify again our existing code. And here's our original code. I'm going to delete some of these comments just to clean things up. And this example will have nothing to do with our nested table type, so I'll go ahead and get rid of this stuff. But we are going to deal with our cursor, so we'll keep that stuff there. Okay, so our cursor, we want to change it up a little bit. Right now our cursor just contains the employee ID. We want to make a decision based on how long the person has been with the company, so we'll include the hire date in there as well. And in our loop here, we're going to actually be performing some updates on the underlying records. Well, to do that, we need to be able to lock the underlying records. And the way we do that with our cursor declaration is we say for update. So whenever this cursor is opened, all of the corresponding records are going to be locked. And we'll talk more about locking and all the ramifications involved in our locking nugget. What I'd like to do is say, look, if somebody has been with the company for longer than 20 years, let's give them a 20% raise. If someone's been there for more than 15 years, let's give them a 10% raise. So we have our if statement. If rec.hiredate is less than sysdate, remember sysdate returns today, we can do some math with our dates. Let's subtract 20 years. So that's 20 times 365. Then we're going to perform an update. We'll say update employees, set salary equals salary times 1.2, where current of, and this clause is used only with our cursors. This is just saying, let's just update our current record in the cursor. And then we say the cursor name, which is empcur. Now, if this case isn't fulfilled, then we go down to the next case. We have an else if, and this is not a typo. It is spelled ELSIF. I suppose the developers of PL SQL decided that extra E was just too much work. Okay, so else if rec.hiredate is less than sysdate minus 15 times 365. Then we're going to update. Everything's going to be the same except we change 1.2 to be 1.1. So we can do just a copy and a paste. You always close off your if with an end if. And we save it and execute. Beautiful. And when we get to our trigger nugget, we'll talk about how to track all these changes in the salary so you know what the salary history is. It's a pretty neat feature. I've already shown you how to loop through a cursor. We used a for loop for that. Let's take a look at some more loops. Now these three chunks of code here are all accomplishing the exact same thing. So there is more than one way of looping. Our first example here is a regular for loop where we say for and then some variable name in and then our number range. And it is always going to count consecutively. There is no skipping over numbers. What's nice about this code is it's really compact. You don't have to explicitly declare your variable because the for loop itself implicitly declares it for you. You also have the option of inserting the keyword reverse. And what this does is it will actually count from 10 backwards to 1. Our second type of loop is what we call an infinite loop. The reason why we call it an infinite loop is if you don't provide an exit statement, you'll end up in this infinite loop. It will go on forever and ever. Okay, so make sure that you have your exit clause. So here you have to explicitly declare your variable. Here I'm defining it to be 1. And then we start our loop. It ends down here. We can execute some code Make sure you have an incrementer, otherwise you'll never get to number 10. And our loop is finished. I'm not a big fan of this type of loop just because it's a lot of lines of code to type. And then our third type of loop is our while loop. Okay, so once again, we have to explicitly declare our x. I'm assigning it here again, and I'm saying, hey, we're going to have this loop while x is less than or equal to 10. So we execute some code. Once again, you have to have an incrementer in here, otherwise you end up with an infinite loop. So I've given you 3 different tools. You choose your weapon. We've talked about most aspects of PL SQL except for exception handling. Let's review the main structure of a PL SQL block. Remember, you have your optional declare. That's where your variables are. And then you have your begin. And from there, until the optional exception clause, is where you have your main chunk of code. And then down here, you terminate it with end. So all of your exception handling goes down here. Now you can have multiple when clauses. Oracle has just a handful of predefined named exceptions. One of them is called no data found. For example, whenever you have a no data found exception thrown, then it will be caught in this chunk of code. So here we would say when no data found, then, and then whatever code you want to have executed. If you have null, it just means ignore the exception. What's important to know about the flow of control here is that in this main body of code, if an exception is thrown and there's an appropriate handler down here, then there is no going back up to this code. So I'll show you in a moment how to override that kind of behavior. Let's look at Oracle's official documentation. I'm pulling up the online docs for exception handling. Okay, and so this is the PL SQL Users Guide and Reference that you get from tahiti.oracle.com. And down in Chapter 10 gives a list of the predefined PL SQL exceptions. They're right here. Okay, so these are the types of exceptions that occur so often that not only do they have a number associated with them, but they also have a name. Now, every single exception under the sun has a number to go with it. So you'll see here that there's the Oracle error code, and then there's the ANSI standard SQL code. And look how these map onto each other pretty nicely. The ANSI standard SQL code is going to be useful for other relational databases as well. So it's portable. So we scroll down a little bit, and here's our no data found, and it has this number associated with it. Now this is one of the few cases where these two numbers don't map onto each other that well, and that's fine. Okay, so it gives an explanation of what happens when we do a select into statement and it returns no rows, then this exception is thrown. And so inside of your exception handling block, you can have a when no data found then clause, and then you can, a couple lines down, you can say when invalid number then, and so on. You can have all sorts of when clauses. If there's not an appropriate exception handler for your exception that was thrown, then you'll get a really ugly error message. We're going to create our own procedure now that has its own custom exceptions and exception handler. Okay, so we're going to call our procedure addEmp, and it's just going to take a few parameters like an employee ID, first name, last name, hire date, and email address. So the way we do that, we say create or replace procedure, and then the procedure name. So I said employee ID, as well as last name, first name, email address, and hire date. As, and here if we have any variables that we want to declare, these would go here. Well, whenever you're declaring your own exceptions, that goes in the variable declaration part. So I'm going to create a hire date exception. And so I say that it is of type exception. And I'm also going to have an email exception variable, and it is also of type exception. And then our begin keyword, and we'll have some checks here. We'll say, well, if our hire date is sometime in the future, then that's not a good thing. Okay, we want to throw an exception. So we'll say if hire date is greater than sysdate, then raise, and then the name of our custom exception. Hire date exception. end if. Always close that off. And also, we can do the same kind of thing with our email. If the email is not in a particular format, we can throw our own custom exception. So we'll say if email is not null and email not like, remember these meta characters, percent means match any character, at sign will match a literal at sign, then a percent, then we want to match a dot, and then a percent. So something something at something something dot something. Okay, that's the pattern we're matching. Then we're going to raise our email exception. End if. And here I'm just going to put a comment. Here we would have some code that would actually add the record into the employee table. We won't bother with that right now. The whole purpose here is to show you how the exception handling works. Okay, so we go into our exception block, and this is where we can say when hire date exception, then, and then we can have some lines of code that react to that type of exception. Just for debugging purposes, I'll say DBMS output, put line, I'm going to print something out that is informative. I'll just say wrong date. And then I can say when email exception, then, and once again, DBMS output, put line. Wrong email format. Okay, so let's go ahead and test this. We end it and execute it. Our procedure's been created. Add emp. So we could add an employee number 500. We'll try Johnson and Julie. And I'm just making up this email address. And then for the hire date, let's give a bad hire date. Let's say that it's a sysdate plus 2. And it comes back telling us, hey, you've got a wrong date. So now you know how to handle your exceptions, and we'll go more in depth when we cover our package nugget. So in this nugget, we talked about why we use PL SQL, mostly for control flow and reusability. Remember our different types of PL SQL code. We've got those anonymous blocks. Remember that special drink that I always order? I have to write it down on paper, and it's like I execute that script every time I want it. And then there are the procedures, functions, packages, and triggers that are all in the data dictionary. We've got our packages, which is pretty much a namespace for our different procedures, functions, and variables. We'll cover that in a whole new nugget. And we've got our triggers, which are just reacting to things, like my daughter's hand in the cookie jar. By the way, I didn't put a mousetrap in the cookie jar. Don't want any phone calls from social services. And then we've got our basic scalar data types. And remember the anchored data types where you say, hey, this variable type is the same data type as this particular column in this table. Then we covered our composite types, specifically the nested tables, so you can create arrays and populate them using the extend method. And then we have ref cursors, which we'll cover in our packages nugget. Our main types of control are the if and if statements, as well as the 3 types of loops. And then our cursors, which are a way of looping through a result set and doing something to it. And then, of course, our exception handling, how to react to things that unexpectedly go wrong. Well, I hope this has been really informative for you, and I'd like to thank you for viewing.